In this lesson, we're going to solve some polynomial equations. Now, quadratic equations are technically polynomial equations, but I'm not going to include that in this lesson. I'm just going to look at our non-quadratic polynomial equations, so something higher than an x squared. Now, the first thing that I would suggest is you look at the degree of the polynomial, and in this particular case, like my degree is going to be 5, so I can get up to 5 solutions. I'm not going to get all 5 if I have imaginary solutions. Those are solutions, but you don't need to count those in this class. Or if I have a solution that repeats. So I may have x equals 2 and x equals 2 twice. But I, most of the time, will come up with 5 solutions in that particular equation. And in this one, my degree is 3, so I should be coming up with 3 solutions. So let's look at a couple examples here. I've already got both of these examples set to 0. You do want to set your polynomial equations equal to 0 right from the start. And really the best way to go about these is just try to factor. And these are going to be set up at this point to factor. We are not going to do the ones that are not factorable, where you're going to have to use the root and the synthetic division. So in this problem, I look at the x to the 5th minus 16x, and I can factor out an x. And then I have x to the 4th minus 16th, which is a difference of squares, and that factors as x squared plus 4, x squared minus 4. Okay, now I could at this point set each of those factors equal to 0 and get my solutions, but I'm going to factor it a little bit further. And x squared minus 4 factors as x plus 2, x minus 2. So now I have the product of x times the quantity x squared plus 4 times the quantity x plus 2 times the quantity x minus 2 equals 0. And by the zero product property, I can say that as long as one of those factors is 0, I have a true statement. So I go and I look at the fact that x can be 0, and that's going to be one solution. X squared plus 4 can equal 0, or I have x squared equals negative 4, x equals plus or minus the square root of negative 4. And at this point, you should notice that it's an imaginary solution, so you can just write that these aren't real, or you can write that you have plus or minus 2i. And then I also have x plus 2 equals 0, so x equals negative 2, and I have x minus 2 equals 0, so x equals 2. Okay, and if you look at how many solutions I have, I'm looking at x equals 0, x equals negative 2, x equals 2, and my two imaginary solutions of 2i and negative 2i, and I should have come up with 5 solutions. Now in this next example, I have a degree of 3, so I'm looking for 3 solutions. This is a 4-term polynomial, so I got to go to my factor by grouping. So I'm going to look at these first 2 and the second 2. I can take out an x squared, and here I get 2x plus 1. Here I'm going to take out a negative 9. Remember the negative because of the fact that I have a minus here. And I get 2x plus 1, which is what I was hoping I would get. So I have 2x plus 1, x squared minus 9 equals 0. Now, the x squared minus 9 can be factored further, but I'm going to leave it like this because the last example I factored it further. And let's just say I have the product of two things equaling 0, so I can use my 0 product property. And here I'm going to get 2x equals negative 1, or x equals negative 1/2. And here I'm going to get x squared equals 9 and use my square root property. And I get x equals, and don't forget it's going to be plus or minus the square root of 9, or x equals plus or minus 3. And those are my 3 solutions, negative 1/2, positive 3, and negative 3. Now, both of these are easy to check. You do have a lot of solutions that you should check. But generally, if your factoring is done correctly and you check 1 or 2 solutions and they work, the rest of them should work. This last example has x to the 4th, so I'm looking for 4 solutions. And this is a trinomial, so I'm going to factor it like we do our trinomials that are just x squared, but instead of having an x and an x, I'll have an x squared and an x squared. I still want to do the multiply to equal negative 20 and add to equal negative 1. So my two numbers are negative 5 and 4. And instead of me having just an x minus 5 and an x plus 4, I'm going to have an x squared minus 5 and an x squared plus 4. So at this point, neither one of these are factorable as a difference of squares because 5 is not a perfect square, and this one's not even a difference. So I don't have a choice. I'm going to have to say x squared minus 5 equals 0, or x squared plus 4 equals 0 by my zero product property. And I can still solve this because they're quadratic. And so I have x squared equals 5, x equals plus or minus the square root of 5. And here I have x squared equals negative 4. So x equals plus or minus the square root of negative 4, which I can write as plus or minus 2i. And I should have come up with 4 solutions because of my x to the 4th here, and I have 4 solutions. Here's 2 plus square root of 5, negative square root of 5, and then my positive 2i and my negative 2i. A couple things to remember about my polynomial equations is to always make sure that it's set equal to 0, and then you're going to use factoring methods. I'm not going to give you ones that you can't factor, so you're going to try to factor these. Watch out when you get x squared equals a number that you put the plus minus so that you get all of your solutions, that you're not missing any solutions. I generally, at the end, once I have all my solutions, I look to see, do I have all 4 solutions? If I don't, is it because one of them repeats? Did I forget to put my plus minus? Am I missing something in one part of it? So those are things that you need to watch out for.